All electricity generated in Iceland is either from geothermal or hydropower. The power plant generates 303 megawatts electricity, 133 megawatts thermal. And here in the background you can see steam coming from the cooling towers. We use geothermal fluids for producing both electricity and water for district heating.
So they're drilling holes and they're letting steam come up to the surface. It's the biggest geothermal power plant in the world. And although it sounds like a green source of energy, they're still emitting CO2, and that is because there's CO2 and other gases are dissolved in the water that comes from the subsurface. It's steam that's being released into the atmosphere, and some of the gases from the water are also released into the atmosphere.
The plant emits 40,000 tons of CO2 per year, and that is about 5% of what a fossil fuel powered power plant of the same size emits. We are trying to fight climate change by reducing anthropogenic CO2 emissions by injecting CO2 into the ground rather than emitting it to the atmosphere. The idea is to put the CO2 back where it came from, just return it.
Now we have shown by now that there is a reaction between the CO2 and the rocks, and the CO2 is converted into carbonates and then stored safely as a mineral in the subsurface. All of Iceland is basalt, volcanic rocks, and they're very reactive with CO2. They're very young, fresh, and they like to react with the CO2 very quickly.
That's just water in there with the gas dissolved in?
Yeah, condensate with dissolved gases. The condensate is steam from the power plant.
Yeah.
And then we co-inject some additional geothermal brine with it into the well to have enough fluid flow to push it all.
So we have been injecting CO2 at this site, and we have monitoring wells downstream. And in these monitoring wells we are looking at the CO2 concentrations, but we're also looking for tracers, basically dyes that we have been adding to the CO2. And we see the dyes arriving at the monitoring wells, but the CO2 is not arriving. So the CO2 has precipitated out of solution and formed these minerals.
Between 80 and 90% of what we injected was mineralized within a year. So very efficient method. And we've had many problems. In order to be able to inject the CO2, we need to get rid of all the gases.
If you open that valve, because there's so much H2S in here, you open this valve and the H2S comes out of the water, you read that in a very short period of time. That is really useful here.
Yeah.
Extra.
Iceland has definitely been affected by climate change. We have loads of glaciers here, and they keep getting smaller every year. And in fact, this year, the first glacier was stated that it is no longer a glacier.
There is movement of fish populations, there is movement of some bird species to different locations. There are certain insects that suddenly appear here that have not been appearing before.
Iceland is over 90% basalt, so fairly unique locations, but nonetheless you have loads of basalt elsewhere in the world, so you can apply the method elsewhere.